Hello friends, this is second video on time, speed and distances. In this video mainly we'll talk about the questions based on this concept. We'll be asked to find the distance given two different speeds with two different times, and we'll be asked to find the distance. So we'll use a direct formula. Distance is equal to product of speeds divided by difference of speeds into difference between arrival times. So the second concept which we'll be using is proportionality. Speed is inversely proportional to time. So in such cases when one quantity is inversely proportional to other, so if the first quantity is increased by 1 upon n, the other quantity will decrease by 1 upon n plus 1. For example, if the first quantity increased by 1 by 4, the other quantity will be decreased by 1 by 5. So let's see the examples here. So here is the first example. A boy walking at 20 km per hour reaches his school 10 minutes late. So suppose he was supposed to reach at 8 a.m. 8 a.m. is the time of the school, let's say. With 20 km per hour, 20 kmph, he is reaching at 8:10 a.m. So he is 10 minutes late. Now he walks, next time he walks at 25 km per hour. So he walks at 25 km per hour. So that time he is reaching 20 minutes early. So that means he is reaching at 7:40 a.m. 20 minutes early of the actual time. Actual time is 8 a.m. So that's what given to us, and we are asked what is the distance between home and school. If this is his home and this is his school, we are asked what is this distance. Right. So as we have just now seen, in such cases we can use many ways to solve this question, but here we'll use two ways. The first way is distance is equal to just now I have told the formula. Distance is equal to speed, product of speed, initial speed and final speed, divided by s2 minus s1 if s2 is greater than s1, into difference between arrival time, So now the difference between arrival times is, initially he was arriving at 8:10 a.m. So now he is arriving at 7:40 a.m. That means difference between these two arrival times is 30 minutes. That's the difference we are talking about here. So let's substitute the values in this formula. So initial speed is 20 km per hour into 25 km per hour divided by 25 minus 20 into the difference between arrival times is 30 minutes, or 30 by 60 hour. So 2. So that is nothing but this 2 will cancel this 10, sorry 20, 2 tens are 20. Now we'll have 10 into 25 divided by 5, which is nothing but 5 2s are 10, 50 km. So distance between his home and school is 50 km. That's one way to solve this. So let's look at the other way to solve this question. The other way to solve this question is here. If I erase this, this was one way to solve this question. The other way to solve this question is by using the inverse proportionality concept. That is, if the first quantity, or if the speed is increased by 20% or 1, so here the speed is getting increased by, so let's see this. So here the speed is getting increased by 5 kmph on 20. So that means it is getting increased by 5 over 20. So 20 was the original speed, it is getting increased by 5, so that's nothing but it is getting increased by 1/4. So the speed is getting increased by 1/4 of the original speed, so that means it is now becoming 25 kmph. So if the speed is increased by 1/4, the time will decrease by 1/5, right? So that means this is the original time. See, the original speed is getting increased by 1/4, therefore original time will decrease by 1/5. So, and that decreased time is given to us. Decreased time is nothing but 30 minutes, because he was reaching at 8:10, now he is reaching at 7:40. So the decrease in time is 30 minutes, so that time is given to us 30 minutes. So 1/5 of the original time is equal to 30 minutes, that's given to us. So therefore original time t is equal to 150 minutes. Now we know the original time, we know the original speed 20 km/h, so therefore the distance is equal to speed into time. So that is nothing but 20 into 150 minutes divided by 60, that is into hours, convert into hours. So that is nothing but 3 to the 6, 3 5 the 15, and 2 10, 2 10 the 20. So that is nothing but 50 kilometers. So that is the distance. So let's see one more question. Here the speed, initially the speed is 10 km/h, then the speed is 15 km. So with that speed he is 15 minutes late. Speed 10 km/h, he is 15 minutes late. So then he increases his speed to 15 km/h, he is 5 minutes late. So if he was supposed to reach at 8, initially he is reaching at 8:15, so then he is reaching at 8:10, right? So the difference between arrival times is 10 minutes. So you can use a direct formula. Distance is equal to different product of speeds divided by difference of speed into the difference between arrival times, that is this difference. So I'll leave it, but I will solve it by using another way. So the another way is the speed is inversely proportional to time. So here speed is getting increased by 5 km/h over 10. That means it is getting increased by 50%. So speed is increasing by 50% here. So speed is increasing by 50%, which is nothing but 1/2, right? Therefore time has to, original speed is increased by 50%. Original speed was 10 km/h, new speed is 15 km/h. That means original speed is increasing by 50% or half. So therefore original time has to decrease by 1/3, and that original decrease in original time is given to us 10 minutes. Originally he was 15 minutes late, now he is 5 minutes late. That means, I'm sorry, here he is reaching at 8 into 8:05. So let me correct this. So here he is reaching at 8:05. He is reaching at 8:05 a.m. So this is 8:05. So 10 minutes difference between arrival times is 10 minutes. So that difference is given to us. So 1/3 of the original time. So 1/3 of t is equal to 10 minutes. Therefore t is equal to 30 minutes. So original time he will take is 30 minutes or half hour. So the distance is equal to original speed into original time. Original speed is 10 kilometers and original time is 30 minutes or half hour. So that is nothing but 10 into half, which is nothing but 5 kilometers. Distance is 5 kilometers. So this question we can solve by using the direct formula method also, which you can try yourself. So let's see few other questions. When the speed of a train is increased by 20%, it takes 20 minutes less to cover the same distance. The speed is increased by 20%, therefore, or 1/5. 20% means 1/5. Speed is increased by 20%. The time has to decrease. Original time has to decrease by 1/6, right? So the original decreased time is given to us. It takes 20 minutes less. That means originally, if it was taking some x time, now it is taking 20 minutes less. That means x minus 20. So the difference, decreased time, is given to us 1/6 of the original time. So 1/6 of the original time is given to us. Speed is increasing by 20% or 1/5. So the time will decrease by 1/6, and decreased time is given to us 20 minutes. So 1/6 of original time is equal to 20 minutes, or 20 by 60 hours. So therefore time is equal to 6 into 2 by 6, or 2 hours. 2 hours. So the original time is 2 hours. So yeah, and that is what we are asked to find. What is the time taken to cover the same distance with actual speed? So the time taken to cover the same distance with actual speed is 2 hours. So let's see another question. So here speed is increased by 25%, or 1/4. 25% means 1/4. The time has to decrease by, original time has to decrease by 1/5. So see, this is original speed is increasing, so therefore original time should decrease by this much. So therefore, and that decreased time, decreased original time is given to us 20 minutes. So 1/5 of the, so time is decreasing by 1/5. So the decreased time, that is 1/5 of the original time, is 20 minutes. That's given to us. So therefore the actual time t is equal to 20 into 5. That is nothing but 100 minutes. That is the original time. So let's see another question. Speed is increasing by 1/6. Speed is increasing by 1/6, right? 1/6. So time will decrease by, original time will decrease by 1/7. So the decreased time is given to us 10 minutes. So 1/7 of the original time is equal to 10 minutes. So therefore original time is equal to 70 minutes. Right. Let's see one more question. A man cycles with a speed of 10 km per hour and reaches his office at 1 a.m. So 10 km per hour, it is, let's say here is his home and here is his office. With 10 km, he is reaching at 1 p.m. sorry, 1 p.m. Now when he cycles with a speed of 15 km per hour, so 15 km per hour, he is reaching at 11 a.m. So the difference between times is 2 hours. Initially was reaching at 1 p.m. Now he is reaching at 11 a.m. That means the difference between times is 2 hours, and that is happening because the second time he is traveling with greater speed, right? He is increasing his speed from 10 km per hour to 15 km per hour. So that means we can compute the original time from here, right? So the original time, this question again can be solved by using a direct formula method. Distance is equal to difference of product of speed divided by difference of speed into difference between arrival time. We can directly get the distance. But let me solve it by using another way. So here the speed is getting increased by 1/2. So speed is increasing by 50%. Why 50%? Because it is becoming 15 km per hour from 10 km. That means increase by 5 km per hour over 10 km. That is 50%, which is nothing but half. So time has to decrease by 1/3, and the decreased time is given to us 2 hours. 2 hours. So therefore that 2 hours is 1/3 of the original time. So 1/3 of the time is decreasing, original time is decreasing by 1/3. That means 1/3 of the original time is 2 hours. Therefore, original time must be 6 hours. So originally he is taking 6 hours with 10 km per hour. With 10 km per hour he is taking 6 hours. That means with 10 km per hour he is reaching at 1 p.m. by taking 6 hours. So he must start at 7 a.m. He must start at 7 a.m. Every day he must be starting at 7 a.m. with this speed, right? So the starting time, he must start at 7 a.m. He starts at 7 a.m. He starts at 7 a.m. So now the next time it is given that the question, other part of the question is, at what speed should he cycle so that he reaches his office at 12 noon? Now we want him to reach at 12 noon at the office. So at what time he should start? At what speed he should start? He is always starting at 7 a.m. right? But at what speed he should start, right? So here starting time is 7 a.m. starting at 7 a.m. reaching at 12 noon. What is the speed? Right? That's given to us. So we should know this distance. This distance we need to compute, right? So this distance is nothing but, we know the time, original time is 6 hours. See, this is office, this is home, right? Same distance he has to travel. Initially he was traveling with 10 km per hour and taking 6 hours, was reaching at 1 p.m. That means we can compute this distance. Distance is equal to speed into time, that is 60 km. That's the distance from home to office. Now what we are asked is, he is supposed to reach in 5 hours. That is, he is supposed to reach at 12 noon. Starting at 7 a.m. he is supposed to reach at 12 noon. So that means 5 hours. He has to cover 60 kilometers in 5 hours. So that speed is nothing but distance upon time. So distance is 60 and time is 5 hours. So 12 kmph. So he must travel with the speed of 12 km per hour in order to reach at the office at 12 noon, right? So the speed is 12 km per hour. In this question what we did is, we computed the time at which he was starting from home, then we computed the distance from home to office, right? Then we solved the actual question. The question was how much speed he should have, or he should start with, in order to reach in 5 hours from home to office. So the speed is equal to distance upon time, so 60 upon 5. So that's the answer. So thank you.